Now let's go to compositions of functions. I want to make sure I point out the notation of f of g of x. It looks like the word fog and can also be written as f parentheses g parentheses of x and then close our parentheses. The way to say it is f of g of x. What this means is that we're going to get a value of x and plug it into our g function, and whatever comes out will be plugged into our f function, and whatever comes out of there is going to be our answer. I'm showing this with the use of function boxes. Thus, we need to realize that the very first thing we plug into our g function is some x value that is in the domain of g. After the x value goes through the g function, what comes out is going to be the range of g. And this range value must equal to a domain value that is in f, so that we can stick it into the f function. And what comes out of the f function is going to be the range value of the f function. To better understand composition of functions, let's do an example with our given f and g functions. Let's say we want to find f of g of 2. We can write this as f of g of 2, which means we must first find g of 2, and then whatever we get, we plug it into the f function to find our answer. Since g of x is equal to x plus 1, we find that g of 2, by substituting 2 for x, that g of 2 is equal to 3. Now we find f of 3. The 3 is from the g of 2. So we substitute 3 for x in x squared plus 2x plus 1, and we get 3 squared plus 2 times 3 plus 1, which is 9 plus 6 plus 1, which is 16. We have found that f of g of 2 is equal to 16. We did not have to worry about ranges and domains in this problem, as both the quadratic and linear functions have both domain and range as negative infinity to positive infinity. In many cases, we will want to find a composition function in terms of x. This means we will not substitute a value for x, we will just insert x itself. Let's find f of g of x. This means plug in x into our g function, and whatever comes out goes into our f function, and whatever comes out of that is our answer. Let's try it for our functions. We will put x into our g function, which is represented by our parentheses plus 1. Therefore, our output will be x plus 1. Now we will put our x plus 1 into the parentheses of the f function, which is represented by the parentheses squared plus 2 times the parentheses plus 1. So the output will be in parentheses x plus 1 to the squared power plus 2 times in parentheses x plus 1 and then plus 1. That needs to be simplified. In order to simplify, first we need to multiply our x plus 1 quantities squared out. That means we need to multiply x plus 1 times x plus 1, either using FOIL or your favorite method of multiplying binomials. We also need to distribute the 2, and in doing so we will get x squared plus 2x plus 1 plus 2x plus 2 plus 1, and then we add like terms. Therefore, we find that f of g of x is x squared plus 4x plus 4. Finding this composed function will also allow us to find that f of g of 2 by substituting 2, and we get 2 squared plus 4 times 2 plus 4, which we can represent with 4 plus 8 plus 4, which is 16. And this is the same value we found above when we had f of g of 2. Let's see what function we generate if we find g of f of x. Remember, that's g of f of x. Recall that this means that we will insert x into the f function first, and whatever comes out will be entered into the g function, and then whatever comes out will be our answer. Let's plug in x into our f function. So I'm going to have parentheses squared plus 2 times the parentheses plus 1, and we will place the x into the parentheses, and the result will be x squared plus 2x plus 1. Now let's insert this into the g function of parentheses plus 1, and the result is, in our parentheses, x squared plus 2x plus 1, and outside of our parentheses are plus 1. And this simplifies to x squared plus 2x plus 2. Notice the composed functions of f of g of x and g of f of x. F of g of x is x squared plus 4x plus 4, and g of f of x is x squared plus 2x plus 2. These functions are not the same. Therefore, we need to make sure that we pay attention to which is the inside function and which is the outside function when composing functions. In fact, f of g of x will equal to g of f of x only on special occasions that we will discuss later in the semester.